So, hi everybody. I'm Hưng, the TIFE. So, my section is we will talk about the TI transceiver interface, and okay. So, we have discussed with you about TI EP product already, and I think it's kind of very so-called heavy. I mean, a lot of information, right? So I hope this section will be lighter and easier for you before we stop for lunch. So the first message I would like to highlight to you is that we have the broad portfolio of the interface product. We have not only the logic and translation solution. We also have like protection device solution, switch, multiplexer, isolation product, and also the transceiver, which is the object. I mean the main object of today session. So. We do have, like, for example, the transceiver. We do have, like, our broad is we have the very broad portfolio with more than 2,000 devices supporting different multiple protocol, as well as we offer many different package options. Okay, so we will talk about the RS-45 transceiver, RS-232 and multi-protocol transceiver. We will talk a bit about like CAN transceiver and SBC, and the last one is LVDS and M-LVDS product. Okay, so this is an overview of the transceiver interface. Like just now, you see that we have many different types of the interface product, but this is for specifically for the transceiver interface. We classify the product into different categories here. We have RS-45, RS-422, RS-232, LVDS, M-LVDS, CAN, and LIN, and SBC, and also the I/O link. SIO. This is one of the standard for the industrial market. Okay, so this chart is showing you the relationship between the cable length and the data rate of each standard. So depending on the needs of your application, so you can select the appropriate standard. Here you can see that, for example, like the RS-45 standard, is very common standard, right? So the cable length can go up to like 1,000 meters, and the data rate is about like 50 megabit per second. When you need a higher data rate, you can consider different standard here, like the LVDS or M-LVDS. For example, like LVDS, the data rate can go up to like 4,000 megabit per second. However, the length of the transmission will be shorter. It's about like less than 100 meters. Okay, so let's talk a bit about the interface selection and design. So depending on your system requirement, you will select the most suitable interface, right? For example, like whether your system need like to transmit what kind of topology you need. You need to transmit the data to many different points, or you just need to point, and what is your data rate, and also the distance you need. From there, and also the signal type. Your signal type is a differential or single-ended. So you will decide your interface based on this kind of this sets of the so-called parameters. And once you decide the interface standard, you will move to the device selection, device implementation. So for the device implementation, the device you need to be comply with the common like parameters for each interface here. And this row showing you some advantage of each standards. Okay, the next one we talk a bit more about the one of the most common standard, which is the RS-485 and the TI RS-485 transceiver. So actually we have TI has so-called the standard RS-485, which can provide you with the physical layer of the RS-485 standard. But with addition to the standard RS-485, our RS-485 device product offers some more additional features, as you can see in the slides here. We do have like integrated ESD or EFT protection. We have like integrated such protection devices. We have like high voltage burst fault protection device family. We have like auto polarity correction device and auto direction selection device. As well as this is one of the so-called very advanced product line here is that RS-485 power line communication, which you can transmit, or you can use, you can transmit the power and also the data using only 2 wires between the 2 RS-485 device. So, okay, so here also highlights some of the benefits of each feature that TI device offer. For example, with the integrated ESD or EFT protection device, you don't need to use the external protection circuit. And it has, this kind of device has high noise immunity without any wrong data transmission. And we also, for example, we also have like auto polarity correction devices. So in the case, the transmission line A and B are swapped because of any reason, the device can be or still can automatically transmit the data in the right order. And the other one is the auto direction here. So again, for this type of device, you don't need to use a so-called an MCU or any other host in the system to decide which direction to transmit or receive the data. And the device here can automatically detect the direction and transmit the data. Okay. There are some other features that TI RS-485 device offers. That we do have the industrial standard package option. Besides the standard package options, we have the smallest RS-485 transceiver in the SOT packages. Because we see a lot of the needs and the demand of using smaller package for the RS-485 transceiver, and that's why we come out with this package. And this is a one like recommendation to do the dual footprint co-layout for the SOT with other standard package like SOC or VSSOP. You can see that the pinout is easier for help us to do the layout, co-layout easily here and conveniently and easily. And so this helps you to have like more than one package option on one PCB. So in case you need the smaller one, you can use the SOT package. Okay, so let's talk a bit about the power lines communication, RS-485 power line communication. So in the with the conventional RS-485, yeah, we need 4 wires for the data transmission, right? Power, ground, and 2 wires for the signal. But with the HVD 8000 power line communication here, we only need 2 wires to transmit the data and also the power on the 2 line, because the data is will be modulated on the power line. And the benefit is very clearly, right? It's very clear that we don't need to use cable with more wires, which will reduce the cable cost and waste. And also, with this type of device, we can transmit DC or AC analog or digital signal on just one pair of wires. Okay, this is one picture of the device. As you can see here, this is one example of the transmission system, including the transmitter and so the receiver here. The transmitter, you can see that the transmission lines only there are only 2. So also the data and also the power will be transmitted over these 2 layers. Okay, so this is an overview of the RS-485 transceiver, half the flex transceiver of TI. So like you can, from here you can see the feature that we discussed just now. We do have like a device with like ESD or EFD protection, or we do have like high voltage burst flow protection, and also we have the where is it? Power line communication device. And you can also see that there are 2 types of the supply voltage of device here. With the device, which the second digit is 5, that means this device is 5 volts supplies, power supplies. With the device that has the second digit here is 4, that is it's a range of the power supply, 3.3 volts to 5 volts devices. And this types of device. Okay, so why do we have 2 types of the power supply group of products here? Because we provide customer user with the flexibility. For example, like in your system, there are only like 5 volts power supply rails. So this one, this type of the product is good enough. And in case your system has like 3.3 volts or just a range of the power supply in your system, then you can consider this type of a product here, which support the range of the power supply. Okay, so this is the just now the half duplex, and this is the full duplex RS-485 transceiver. And again, we also have different type of the features integrated inside the chip, and we will also have the different option power supply option here. Just one thing I would like to. I forgot to mention. Okay, so for the device that has a high voltage burst flow, is very I think helpful for the user to design for the in terms of the system that easy to get accidentally got short from the during the runtime. So for example, the transmission line could be shorted to the power supply or any other external factors such as like lightning strike or something. So with this high voltage withstand capability of the device during the full condition, the system, of course, the system stop working. But with this type, because the device can withstand the high voltage, so when it will not be your system cannot be will not be damaged, permanently damaged. So just when the fault condition removed, the system can go back to work as normal. Okay, so these are some supporting information when you are working with the TI RS485 device, and you want to look for the information, additional information. So here, from TI website, you can, for example, you are already using TI RS485, but you want to know, okay, so is there any other newer device or upgrade device? You can use this. You can find the information under the product folder. When you search for one part number, we always provide you with the additional information, like what is the similar product, what is the alternative option, which is the newer product. Okay. So in case you want to compare the parameters between the different products, you can use this Excel sheet. This tool you can download from TI E2E forum. This is the link. I think inside the material, you can use that link to navigate to where you can download the Excel sheet to have this kind of information. This is the cross-reference tool. Okay, so just now, those are the tools to support you when you work with TI RS485. But in case you are not using TI RS485 yet, and you are using different supplier RS485, and now you want to know what is the product TI RS485 that can work for you, you can use this kind of cross-reference tool. You just need to enter the part number of the device that of the software that you are using, and then TI will provide you with the list of the alternative options. These are some design resource. We do have like F-Note. I also have some training video, provide the very basic training for the user. We do also have TI reference designs that implement the RS485 for different application. You can also take a look and use it as your friends. Okay, so that is the RS485. Next, I will talk a bit about the RS232. So I think this is also another most common standard that we have been using, right? So we do split the RS485 232 portfolio into 4 groups of products here. We have like flexible single supply product. We have high ESD transceiver. We have high speed transceivers and also low voltage transceivers. So I think this one should we skip. We jump to this one. I think this slide is easier to talk and easier for us to discuss here. So this is a RS232 selection guide. From this table, you can see that there are different there are options for the TX and RX, which means the number of the transceiver and also the receiver inside each chip. It's because it depends on your requirement, right? Sometimes you just need to transmit data. You don't need to like just simple like transmit and receive data. You can use one transmitter and one receiver. But in case your RS232 communication, you need like additional signal for handshaking, right? So you will need additional transmitter and receiver. So that's why we have different options here. And one thing I would like to note here is that we do have like devices that support like 1.8 volts power supply. One benefit of using this one is that in case your system I/O voltage is just 1.8 volts, so you will have like 1.8 volt power supply to provide for the I/O system, right? For the I/O. So if you use the RS-485, RS-232, that has like higher supply voltage range, maybe more than 3.3 or 5 volts. That means you will need to design additional power supply rails to provide the power supply for the RS-232 device. But with this device, this guy, you don't need to design additional power supply rail. So the whole system just needs 1.8 volt power supply. So this device can create like RS-232 voltage level like plus minus 5 volts, plus minus 9 volts, or plus minus 12 volts or 15 volts by using just one single device. And this will simplify and also simplify your design and also like reduce the system cost. Okay, so beside the RS-485 and RS-232 transceiver separately, we have like multi-protocol devices. Yeah, the device in this family can support so-called dual standard. We have device like here. We support the RS-232 and also RS-485. And these are the options of the family. We have three options. Currently, we have 3 options here. Okay. Next, we talk a bit about the CAN and CAN transceiver and SBC, CAN SBC. Oh. Okay. So for CAN portfolio, we have very broad portfolio. We have CAN FD, and CAN FD SiC product. Our device can support like 3 volt system or 5 volt system, and the maximum data rate can go up to 8 megabit per second. We have high performance product because we are featuring the some protection feature like the ESD and also the high voltage bus 4 also. And one option just now, like similar to the RS-485, that we have the small package option for CAN device. Here's the showing you the 3.3 volts CAN transceiver portfolio. Okay, and this is the 5 volts. You can see that bus protection can go up to like minus 70 volts to plus 70 volts. Okay, so beside the CAN transceiver, we have the CAN SBC. So I think this type of the product is quite used in the automotive application, where we integrated many function into one single chip. We have of course this is the CAN, so we have the CAN transceiver. We also have we integrate the DC-DC converter, or maybe LIN transceiver, and also LDO and switch inside one single chip. So this have like optimized because we put everything inside one single chip, so the board space will be smaller. And because this is a one single chip, the power consumption can be reduced because we can control each portion of the chip. And this is one of the TI CAN SBC. You can see here, we have the LDO, we have the CAN transceiver. Yeah, and also other some protection feature inside one single chip. So this is the evaluation board and also the reference designs. All this information you can find on from ti.com. And again, this is like the support design support document. You can see find many different application notes for CAN. Okay, so the last one is LVDS. I'm not sure if any one of you you can have already used this the interface in your product, but this is the summary, the comparison between the standards. So like also again, like just now you saw the chart, right? So the LVDS and the M-LVDS has the very high, so can consider highest data rate transmission. In terms of the compared to the most common standard like RS-485 or CAN or yeah. And the difference, one of the main difference between the two LVDS and M-LVDS is the bus topology that they support. For example, like LVDS, it support like point-to-point and multi-drop, and M-LVDS, beside point-to-point and multi-drop, is also support multi-point. Sorry. Yes, multi-point transmission, data transmission. Okay, so this highlight some product feature. We do have okay. So this is one thing I would like to highlight here is that we do have the because with the LVDS the device transmission here, you will need the termination register. So we integrate the termination register inside the chip. So yeah, it's provide cost and space saving solution to the user, to the design. Yeah. You can also find the selection guide in the. Okay. Yeah. You can also find the selection guide inside the material, the seminar material here. We do have like automotive, and also some additional feature here like fail-safe and high ESD, integrated termination, or YV command mode. Yeah, again, so in case you are not using TI, you can, and this is a chance to take a look at TI and consider using TI. And if you are using this kind of the supplier, then you can try to consider TI. And any request, any question, just let us know. Yeah. I think that's it. You have any question for me? Yeah, please.
Okay, thank you very much for your explanation. So I have question related to the termination resistor. So I just saw it in the LVDS, but is it also available in the CAN transceiver? And the second question is whether the device that equipped with termination resistor can be disabled for, let's say, we have some ICUs using this kind of transceiver, but only termination is we require 2 or 1 point. Can we disable the others? Thank you very much.
Okay, so as I know, for example, for just now you're asking about the CAN, right? As far as I know, we don't have such a device yet. If I'm not wrong, yeah. And I think for the second one is that the integrated resistor. I think I need to check in details whether the resistor can be disabled or not on the network. Yeah.
Okay. Thank you.
Yeah.
Yeah. Thank you for your presentation. I would like to ask you about the power line communication.
Okay.
THVD 8000.
Yeah.
How many devices can connect it? What is the maximum device can connect it to the one line?
Okay, thank you for the question. Actually, because it's RS-485 standard device, right? So as the normal RS-485 device, it can support up to 256 devices on the network.
Okay.
Yeah, but one thing to know is that it depends on how we select the frequency for the modulation. Yeah, it will impact the maximum number of the device on the network. Because just now you mentioned, you see. Okay, let me think. Let me go back to a bit down on this. Okay, so because here we need to do the modulation and demodulation to modulate the signal into the power line, and also to filter out the signal from there. So it is about the modulation. So we will need to select the frequency for this modulation. So this selection will impact the number of the maximum device can be used on the same network. Yeah.
And if you, for example, if we want to use DC 24 voltage, and from the output of the DC voltage, we need to use inductor, or just we can directly connect it to the system.
We need to use the
inductor,
the so-called filter circuit.
Okay,
yeah.
We need the inductor,
yes,
before
yes.
Go to the line, yeah.
Yes.
And when we want to reduce for example, we want to use the microcontroller to the system, yeah, and then we take the power from the line, and then also we need also inductor for this.
Yes. Yes.
Okay. Can we use this system also for the CAN bus?
I am not so sure, but in my opinion, first of all, we don't have such CAN product yet. But yeah, because it depends on it's about the physical layer of the standard. We do this device is designed specifically for the RS-485. Power line communication.
And for the capacitor and inductor, is what we use is need to have some calculation, for example, to get the correct
value,
capacitor
right,
and inductor.
Yes, we do have the so-called the design document discussing how to do the calculation for such component in the system. Yeah.
It means that we actually not need to use a THVD 8000 because now we use SNXT 65.
Yes.
Also can do this.
Yes, correct. Yes, correct.
How about the price of the THVD 8000? What is the cost?
What is the cost? Okay, so let me quickly check the web price information for you. THVD. So the 1KU price you can see on TI website is $2.277 per piece. Yeah. But this is just like for your reference. The price is always negotiable, right? So when we use TI, we can discuss the price. Yeah, the detailed price. Yeah.
Okay, thank you.
Yeah. Any other question? So I think that it's about time for lunch. So if you have any additional question for me, we can discuss offline. But now I think that for all of us, we can stop for break and for lunch now. Thank you for your attention.